Now starting a new chapter, limits and derivatives. First topic is limit of function. Now to understand what means a limit of function, taking one example. Suppose that I am taking a function fx equal to x square. Its graph is x-axis, y-axis. Say it is parabola y equal to x square. This is y equal to x square. So something like this. Now here I am taking a number from domain. Suppose somewhere here this number, somewhere here this is 1, this is 2. As for example, this number is 2. 2 belongs to its domain of this function. At x equal to 2, x coordinate of this point is 2. Putting x equal to 2, f of 2 is 4. So this number will be 4. So this is a point 2, 4. It's a point on this curve. Now on left to 2, suppose somewhere here there is number 1 and here there is 3. Now see, I am changing values of x. X I am changing and changing from 1, 2 towards 2. Means taking from this interval, going towards this direction. As for example, say here, value of x. I am taking value of x, then calculating value of fx. Suppose x is 1.5. X is 1.5, then 1.5 square is 2.25. Suppose now I am taking x 1.6. Then 1.6 square is 2.56. Continuing this, going near and near towards 2. Suppose x is 1.9. Putting 1.9, f of 1.9 is 1.9 square, that is 3.61. Now if suppose, so say 1.5, then I have taken 1.6, going near and near towards 2, 1.9. Now I am taking 1.99. So putting here 1.99, 1.99 square, it is equal to 3.9601. Go near and near towards 2. Suppose I take here 1.999. If we take 1.999, then its square is, calculating square of 1.999, see what is happening. 1.999 into 1.999 into 1.999. So this will be 3.996. Going near and near towards 2. Suppose I am taking 1.9999. So here taking 1.9999 into 1.9999, so this is equal to 3.9996. So say in this procedure what I have done, I am changing value of x going near and near towards 2. So x is changing values from left side of 2. X tends to 2 from left side. See, x tends to 2. Here x tends to 2 from left side. X tends to 2 from left side. Then what is happening here? See, fx is going near and near towards 4. Here as x is going near and near towards 2 from left side, observe on the y-axis. See here, images are going near and near towards 4. So x tends to 2 from left side, fx tends to 4. Or value of limit is going near and near towards 4. Or we can say limit of fx is 4. This statement can be written as limit of fx is 4. So this can be written in symbolic way by this method as x tends to 2. From which side? From left side. So use this notation. X tends to 2 from left side. Limit of fx equal to 4. As x tends to 2 from left, limit of fx is 4. Or this statement can also be spoken as left hand limit of fx. Left hand limit of function fx is 4 as x tends to 2. So that is the meaning of a left hand limit of function. Now we are talking about right hand limit. See, we are discussing at 2. Our discussion is at 2. When x is going near and near towards 2, what is happening on fx? Now talking on this side. Now I will change value of x going near and near to from right side. So another table, here x, here fx. Here changing values. Say, suppose I am going to near and near towards 2 from right side. Suppose I am taking 2.6 or take 2.4, then take 2.3, then take 2.1, then take 2.01. Values are coming closer and closer to 2.01, 2.001. 2.0001 like this. Now if x is 2.4, 2.4 square is 5.76. Now x is 2.3, so 2.3 square is 5.29. 2.3 into 2.3, that is 5.29. 2.1 square is 4.41. 2.01, so taking 2.01 into 2.01, that is 4.04. Put 2.01 2.001. Here we add one more 0. 2.001. 2.001, putting here 2.001, 2.001 into 2.001. So this is 4.004. Now taking this number 2.001, so taking 2.001, now 2.001 into 2.001, that is equal to we are taking 3 zeros. 2.0001, 2.0001 into 2.0001, that is equal to 4.0004. So look here, what is happening? X is 2.4, then 2.3, then 2.1, then 2.01, 2.001, 2.0001. X doesn't touch 2. X is going near and near towards 2. At the same time, fx is going near and near towards 4. X is going near and near towards 2 from right side. So taking this value of x, this is fx. Taking this value of x, here this is fx. Taking this value of x, we are getting here fx. So as x is going near and near towards 2, we are getting values coming closer and closer to 4. So this means that as x tends to 2 from right side, as x tends to 2 from right side, limit of fx is 4. So this is the meaning of this experiment. As x tends to 2 from right side, this is right side of 2, this is left side of 2. Here values are taken from right side, here values are taken from left side. So then fx is going near and near towards 4. So this in symbolic way can be written as this was the statement for left hand limit. Now for right hand limit, this can be written as limit of fx as x tends to 2 from right side. This notation is for right side. X tends to 2 from right side. It is equal to 4. This can be spoken as left hand limit of right hand limit of fx is 4 as x tends to 2. This can be spoken by two ways. As x tends to 2 from right side, limit of fx is 4. Right side word I am joining with 2. X tends to 2 from right side, limit of fx is 4. Now right side word I am joining with a limit. Right hand limit of fx is 4 as x tends to 2. So we do not speak right side word 2 times. So this is a right hand limit of fx. So left hand limit and right hand limit are equal. Here left hand limit and right hand limit are equal. So we say here limit of fx x tends to 2 from left equal to limit of fx x tends to 2 from right side. Left hand limit is equal to right hand limit, so we say limit of fx as x tends to 2 exist, and it is, see, left hand limit is 4, right hand limit is also 4. This is 4, this is 4, so limit of fx as x tends to 2 is 4. For existence of limit, left hand limit and right hand limit must be equal. Then we say that limit of function exists, and it is equal to the number which is for both limits. It must be same. So here now I am putting definition that if limit of fx x tends to 2 from left side equal to limit of fx x tends to 2 from right side, it is equal to, suppose this number is L, then we say limit of fx x tends to 2. See here, this 2, it can be any real. This discussion was for 2. Similar discussion can be done for 3. Similar discussion can be done for -2. So this can be any real. So for any real, I use symbol A. Limit of fx as x tends to a from left side equal to limit of fx as x tends to a from right side equal to L. Then limit of fx x tends to a exists, and it is equal to L. Here A belongs to domain of this function. We are discussing domain, any number which is belonging to domain of function. Here 2 is an element in domain of this function. Now, when we say limit does not exist, suppose sometimes what happens that if there are many functions in which if you find left hand limit and right hand limit, if sometimes you find not equal, suppose here value is 4 and here value is 5, this is 5, this is 4, that means not equal. If these values are not equal, then what we say, this limit does not exist. Let me explain one example showing that limit does not exist. I have to change the example to understand that when we say limit does not exist. Suppose that I am defining function fx equal to x square, where x is more than or equal to 2, and fx equal to 2x, where x is, here I take x less than or equal to 2, here x more than or equal to 2. Or we can take here x square plus 1. So see, its graph. here what will be happen, if we observe graph of this function, then function is changing its formula at 2. Here the number is 2. At 2 function is changing its formula. Y equal to x square for x less than or equal to 2. For x less than or equal to 2, if this is graph of y equal to, this is graph of y equal to x square. X equal to 2, we are joining here, we are taking here sign of equality, here sign of inequality. For x equal to 2, f of 2 is 4. For x equal to 2, f of 2 is 4. So this point is included in graph. For x equal to 2, fx is 4 and it is obtained by fx equal to x square. This is fx equal to x square. So this is graph for x less than or equal to 2. Now for x more than 2. For x more than 2, here I am putting arrow. This is going up to infinity in upward direction. Here graph is stopped at 2. Now for more than 2, what is happening? Fx is x square plus 1. So fx is x square plus 1. So that means here graph will be like this. This is graph of fx equal to x square plus 1. Means if you take here 2, f of 2 is 5, f of 2 is 5, but 2 is not included here, so we keep this point deleted. See, these values are 1 greater than these values. So after x equal to 2 onwards, graph of x square plus 1 will be 1 unit above to this curve. If you continue this graph, then it will be something like this. So this is complete graph of y equal to x square. But this part is for x less than or equal to 2, x more than or equal to 2. The graph will be parallel to this first graph, but 1 unit above. Points on this graph will be at 1 unit higher than the points of first graph. Means from first graph, if this is the image for 3, then here image for 3 will be 1 unit above. Now look here. So here what will happen? The limit of fx, x tends to 2 from left side. When x is coming towards 2 from left side, this is happening. Fx is going near and near towards 4. And when x tends to 2 from right side, that means, see here, when x is coming towards 2 from right side, then what is happening? See here, you can see what is happening. Values are coming near and near towards 5. This is happening. So limit of fx when x tends to 2 from right side, 5. So left hand limit is not equal to right hand limit. Limit of fx, x tends to 2 from left is not equal to limit of fx x tends to 2 from right side. These are not equal, therefore limit of fx x tends to 2 does not exist. So if limit does not exist, this will happen. So maybe possibility of a gap between curve, there will be gap. So statement for this example, if limit of fx x tends to a from left is not equal to limit of fx x tends to a from right side, then we say limit of fx x tends to a does not exist. Say here limit of fx x tends to a from left side, this is read as left hand limit of fx as x tends to a, and limit of fx x tends to a from right side, this is read as right hand limit of fx as x tends to a. So this is a meaning of limit of function, when it exists, when it does not exist. Now working rules. Limit of fx plus gx as x tends to a, it is equal to limit of fx as x tends to a plus limit of gx as x tends to a. It means limit of sum of two functions is equal to sum of their individual limits. Similar rule is for minus, means limit of difference of two functions is equal to difference of their individual limits. Second working rule, for any constant k, limit of k times fx x tends to a, limit of k times fx x tends to a is equal to k times, means k we can take outside, k times limit of fx as x tends to a. Third rule, limit of fx upon gx as x tends to a, it is equal to limit of fx as x tends to a upon limit of gx as x tends to a. Limit of quotient of two functions is equal to quotient of their individual limits, but here condition is that this denominator must be non-zero. If this denominator is non-zero. Limit of gx must be non-zero. Then this exists. Then if fx is less than or equal to gx less than or equal to hx, these are three real functions, and limit of fx as x tends to a, it is equal to limit of hx as x tends to a, limit of this function and limit of this function as x tends to same number a. If this is equal to L, limit of this function is L, limit of this function is L, same limit of these two functions at x tends to a, then limit of this middle function as x tends to a, it is also L. This is said to be sandwich theorem. It is a sandwich theorem. If limit of first and third function are same, then limit of middle function is also same. Now results. First result is limit of x raised to n as x tends to a. Limit of x raised to n as x tends to a, it is equal to, replace x by a, so a raised to n. That means, say here, explaining few examples. Limit of x raised to 4, x tends to 3. So replace x by 3, so this is 3 raised to 4. So it is 81. Second, limit of 3x square minus x plus 1. This is a polynomial function. So to find its limit, replace x equal to 2. So 3 into 2 square minus 2 plus 1. Upon this is value obtained by replacing x by 2. So this is 4 into 3, 12. 12 minus 2 plus 1, 13 minus 2, that is 11. Suppose limit of x square minus x minus 6 upon x square minus 2x minus 3, x tends to 3. This is equal to, now see, if you keep here x equal to 3, then what will happen? 3 square is 9 minus 3 minus 6 upon 3 square is 9 minus 6 minus 3. See, denominator we are getting 0. Here we are getting 0 in denominator. Denominator 0 is not allowed. Just we discussed working rule. Limit of fx upon gx equal to limit of fx upon a limit of gx. It is allowed when this is non-zero. So here, because denominator, limit of denominator is 0, substitution of this value is not allowed. So what we do? First of all, we have to convert this rational function in simple form. So see, simplifying this, here what is happening? Factorizing this, factors are x minus 3, x plus 2. Here factors are x minus 3, x plus 1. So say this is cancelled. something will be cancelled, due to which problem was produced. Here what was the problem? 0 in denominator, that was the problem, and it was produced due to this factor. So reason for problem is cancelled. Now whatever is left, put as it is, x plus 2 upon x plus 1. Now putting x equal to 3, if denominator is non-zero, then it is allowed. So putting here x equal to 3, this is non-zero. So we are allowed to put value. Put here 3 also. 3 plus 2, 5 by 4. This is limit of this function. So that is application of this result. Second result is limit of x raised to n minus a raised to n upon x minus a. X tends to a. It is equal to n times a raised to n minus 1. Limit of this function as x tends to a. So to understand this example, to understand this result, here I am taking example. This is result 2. Example is limit x tends to 2, x is to 4 minus 16 upon x minus 2. Say here, if you keep x equal to 2, this will be 0. So directly we are not allowed to put here 2, here 2. But observe the pattern. The pattern is, you can match this pattern with this form. X raised to n minus a raised to n upon x minus a. Say this can be expressed as x raised to 4 minus, now 16 is 2 raised to 4 upon x minus 2. So here this is variable. Variable is always on the left of the arrow in every question. This number is always constant, which is on the right hand side of arrow. So this is variable. Same number must be here. A. If this is 2, here there should be 2, 2. If this is minus 2, there should be here minus 2, minus 2. And minus is already a part of this pattern. So now check here this pattern. See, this is x, so x, x. This is 2, so 2, 2. And minus is must as a part of pattern. So by this formula, this is equal to, here this is n. So n times a raised to n minus 1. So this is 4 into 2 cube, that is 8. So limit is 32. Second question, limit x tends to minus 1, x raised to 2021 plus 1 upon x plus 1. So here x tends to minus 1. Now there is a hidden pattern. Pattern of this form is hidden in this expression. This minus is not visible here, but it can be created. Say here this is odd power, x is to 2021. Plus 1 can be expressed as minus of minus 1. This plus 1 can be expressed as minus of minus 1. Now this is minus 1. And if we keep here 2021 over minus 1, then value remains same. Still it is minus 1. So minus minus plus 1. Without changing given value, we can change its pattern. Now look the pattern. See, x is variable. X is variable. Minus is a part of a pattern. and this is constant. Here it is a. X tends to a. This is a. This is a. So by this formula, it is 2021. N is 2021 into minus 1 raised to 2021 minus 1. So this is 2021 into 1 minus 1 raised to even power. This is plus 1. One more question. Suppose limit x tends to 2, or we take 3, x raised to 5 minus 343 upon x raised to 3 minus 8 or 27. X raised to 5 minus 343 upon x raised to 3 minus 23. So see, here limit x tends to 3, x raised to 5 minus 343. 343 I am putting as 3 raised to 5. X cube minus 27 is 3 cube. Here in this pattern, power is in numerator, not in denominator. Power is in numerator and denominator, both it is in this question. We don't want in denominator. So what we do? We now divide numerator and denominator by x minus 3. So see, this pattern we have created in numerator as well as denominator. So it is like limit of fx upon gx, and the limit of fx upon gx is limit of fx upon limit of gx. Limit of fx upon gx is limit of fx upon limit of gx by working rule. Now application of this formula 2 times. See, application in numerator, n is 5, say n is 5, a is 3. So by this formula 5 times 3 raised to 5 minus 1. Now application in denominator, a is 3, n is also 3. N is 3, so 3 times 3 raised to 3 minus 1. So this is 5 into 3 raised to 4 upon 3 into 3 square. So this is 15. Limit of this function is 15. To evaluate this function, say first function, limit of this function as x tends to minus 1. Say to find limit of any function, if any rational function is given, always check denominator. Put this minus 1 in denominator. If you keep here minus 1, then minus 1 minus 1, so it is minus 2, and minus 2 is non-zero. If denominator is non-zero, then we are allowed to put value in denominator as well as numerator. Hence put value in numerator. So here minus 1 raised to 10 plus minus 1 raised to 5 plus 1. So this is equal to minus 1 raised to 10 is 1, minus 1 plus 1 upon minus 2. So this is minus 1 by 2. Say in this question, Here given condition a plus b is not equal, a plus b plus c is not equal to 0. Put x equal to 1. Put x equal to 1 in denominator. So putting here 1, c into 1 square plus b into 1 plus a. Putting x equal to 1, denominator is a plus b plus c, which is non-zero. So we are allowed to put value 1 in numerator also. So put in numerator. So it is a plus b plus c. So this is 1. Now here, if you keep x equal to 3 here, so 2 into 3 square, 5 into 3 minus 3. So this is 9 into 2, 18. 18 minus 18 is 0. Denominator is 0. So we are not allowed to put value. When the denominator is 0, don't put value. Always focus on denominator. Numerator 0 is allowed, not denominator. So here, if denominator is 0, that means there will be something which will be the reason behind 0. So that part will be removed. So in that case, we have to convert this rational function in simple form. Simple form such that in that simple form, if you put value x equal to 3, then denominator of simple form is non-zero. So here we factorize. So factorizing this, see here 2x square minus 5x minus 3. I am putting factors of this polynomial. 2x square minus 6x plus x minus 3. So this is 2x common, x minus 3 plus 1 common, x minus 3. So x minus 3, 2x plus 1. X minus 3, 2x plus 1 are factors. Here x is to 4 minus 81 has factors x square minus 9, x square plus 9. Still we can factorize this. X square minus 9, x minus 3, x plus 3, x square plus 9 keep as it is. So this will be cancelled. So what is left? X plus 3, x square plus 9 upon 2x plus 1. Now see, this is simple form. Now if you keep here x equal to 3, this will be non-zero. So continue simplification until you get non-zero. Until that step, you continue this symbol of limit. Limit x tends to 3, limit x tends to 3, limit x tends to 3. Continue this symbol with every step. And then don't write this symbol, this term, when you substitute value. So putting here in now x equal to 3, 2 into 3 plus 1. Putting here 3, 3 plus 3, 3 plus 3, 3 square is 9 plus 9. Say x equal to 3 is substituted. When you substitute, don't put this limit. So this is 3 plus 3, 6 into 18 upon 7. So 108 upon 7. This is required limit.